Hello, students, and a very warm welcome. Today, we are going to begin a very interesting chapter from your Class 9 chemistry syllabus, Matter in Our Surroundings. I want you to take a moment and just look around you. What do you see? Maybe a book, the chair you're sitting on. Now, think about the air you're breathing or the water in your bottle. You might even smell something delicious cooking in the kitchen. Have you ever wondered, what do all these very different things have in common? In today's lesson, we're going to follow a clear path to understand the very basics of matter. First, we'll find out what matter actually is. Then, we'll look at some early ideas about it. And after that, we'll do some investigating with a few simple experiments to uncover its true nature. All right, let's dive right in. First up, what exactly is matter? Let's build a proper scientific definition for all these things we can see, feel, and even smell around us. You see, scientists have a simple two-part definition for matter, and that's the name they give to basically all the stuff in the universe. For anything to be considered matter, it has to meet two conditions. It must have mass, and it must occupy space. Let's break that down. First, mass. Now, don't let the word confuse you. For now, just think of mass as the amount of stuff that's packed into an object. A big rock obviously has more stuff in it than a small pebble, right? That just means it has more mass. The second condition is that it must occupy space, and the scientific term for that is volume. Think about when you blow up a balloon or pump air into a bicycle tire, the air takes up all the space inside. That space is its volume. So based on our definition, all these things you see on the slide, they are all matter. Your book is matter, and here's a key point. Even the air, which you can't see, is matter. Why? Well, because it has mass and it fills up space. It's really important to remember that just because you can't see something doesn't mean it isn't matter. Now that we have a modern scientific definition, let's take a quick look back in time. Long before we had science labs, people were still very curious about their surroundings. Ancient Indian philosophers, for example, had their own fascinating ideas about what everything was made of. They classified all matter into 5 basic forms, which they called the Panchtattva. That's air, earth, fire, sky, and water. They believed that everything, whether it was living or non-living, was made from a mixture of these 5 elements. This was a really important idea in history, but as we'll see, modern science gives us a different explanation. And this brings us to a really big question that puzzled scientists for a very long time. Is matter continuous, like a solid block of wood with no gaps at all? Or is it particulate, meaning it's made up of tiny individual bits, kind of like a pile of sand? Well, let's find out with a simple activity. We can figure this out with a simple experiment, one you might find in your textbook. So imagine we're in the lab right now. We take a beaker, we fill it about halfway with water, and then we carefully mark the water level. Next, we add a spoonful of salt and stir it, and we keep stirring until it seems to disappear completely. Now, I want you to pause and think for a moment. We've added something to the water, the salt. So logically, shouldn't the water level go up? What do you think? But surprisingly, it doesn't. If you were to check the mark on the beaker, you'd see the water level hasn't changed at all. So what happened? Where did the salt go? Did it just vanish? Well, here's the brilliant explanation. The salt didn't disappear at all. What happened was, the salt broke down into tiny, tiny particles, and those particles slipped into the empty spaces that already exist between the particles of water. They just filled in the gaps. So this simple activity proves something absolutely crucial. Matter isn't a continuous solid block. It is particulate. It's made of tiny particles, and there are spaces between them. Okay, so we've established that matter is made of particles. That leads to the next logical question, doesn't it? Just how small are these particles? Can we even see them? Let's investigate this with another activity. This time, we'll use a chemical called potassium permanganate. We only need 2 or 3 tiny crystals. They have a very strong dark purple color. We dissolve them in 100 milliliters of water. Then, we take just 10 milliliters of this purple solution and mix it with 90 milliliters of fresh, clear water. And we're going to repeat this process of diluting the solution over and over again. Now, watch what happens. With each dilution, the color gets lighter and lighter. But here's the amazing part. Even after diluting it 5, 6, 7, or even 8 times, the water is still colored. It might be a very faint pink, but that color is definitely still there. This result is incredible. What does it tell us? It means that there must be millions and millions of tiny particles in just one of those little crystals. As we keep diluting, those particles just keep spreading out. You can think of it like perfume. One spray can fill a whole room because its tiny invisible particles spread out and reach every corner. Your textbook puts it perfectly, and this is a great line to remember for your exams. The particles of matter are very small. They are small beyond our imagination. We can't see them, not even with the most powerful microscopes. That's just how incredibly small they are. All right, let's quickly summarize the key characteristics we've learned about the particles of matter. Pay close attention here because these points are the foundation for everything that comes next in this chapter. So, what have we confirmed today? First, matter is made of particles. Second, these particles are unimaginably small. Third, as our SALT experiment showed, there are spaces between these particles. Now, there are two more crucial points that we'll explore in detail later. These particles are constantly moving and they attract each other. Keep these 5 points in mind because they are the key to understanding everything else about matter. This leaves us with a fascinating final question to think about. If a wooden table and the water in a glass are both made of these tiny particles with spaces between them, then why is one hard and solid while the other flows freely as a liquid? The answer lies in how those particles behave, which brings us to our next topic, the states of matter. Thanks for joining me today.